Okay, so today will be the webinar of our first session where we'll see the topic of today webinar will be how upfront design for a manufacturing tool could be used by the foundry man or by the OEM to understand in the shortest possible of time about the casting part geometry and where we have the higher masses which are likely to get the hotspot or shrinkage later on. So the purpose of this webinar is to understand in what minimum possible of time, whether it's at the RFQ stage, at the getting system design stage, or any way other, where user can find out the very much informations about the casting part, about its its mass distribution, location where hotspot or shrinkage could arise, where they should put riser, where the height exothermic sleeve could be required, and so on and so forth. So this kind of questions can be answered by the DFM tool, which is not actually the simulation tool, but this will be useful for the designer at the early stage to decide quickly about the gating system, so on and so forth. Right. So the purpose of this will be how we can do this way, this complete requirement of different casting part and its geometry. So the smart introduction about this DFM tool is the name is the Geo Designer, and this will be developed. This was developed by the C3P Group, which is based in USA, and the name of the software is called Geo Designer. Uh, this will be the Auto Design Online. What we are representing them in India. We are based in Baroda in Gujarat, and we are representing this company in India. They are expertise in the casting and simulation software for stamping as well as casting parts. And this tool is not a simulation software, but this tool will be used before we actually do the simulation or the trials. Now let's imagine if you receive some RFQ, you have received the drawing, you have received the casting part model or something like that. But how would you decide what is the complexity involved in this casting part? What should be the cost of this casting part depend on its complexity. How many riser will you require? Whether you will require any exothermic sleeve or not? Which area is likely to get shrinkage? Which area will require the chill? Now, these are the questions which are likely at the designing stage as well as the RFQ stage in order to understand the complexity of this casting part, in order to understand the how this part will later on will lead to the criticality when we actually develop it. So in this case, what we will see is that quickly how this software works. This Geo Designer is basically upfront design for manufacturing tool, which helps engineers at the early stage, as I said, to decide various things to know. That will be the ensures that it will reduce the product development time and the cost. Many a times we have seen in the foundry that they develop the tool, they develop the pattern, they decide the gating system, and then when they find the shrinkage and porosity, then they try to use the simulation or TFM tool, which should not happen. So the TFM tool should be rightly used at the upfront when you are deciding the gating system, riser, and so on and so forth. So this will reduce the cost and rework, and the pattern will be with less rework will give you further better quality in terms of output of the custom part. Now, on other word, if you see this software, it is as good as a virtual X-ray method. That means this software will highlight you exactly the location which are likely to get the shrinkage and porosity in your X-ray method. So this software can be also seen as a virtual X-ray method without foundry trials. Now this is very important. You can identify the shrinkage and hotspot without foundry trials within few minutes, and I will show you practically as well. Again, this is a DFM tool based on the mass distribution and the heat distribution in the inside the casting part. Please note the software is not the simulation software. That means it does not consider the pouring temperature, liquid and solid temperature, the chemical composition, and so on and so forth. This works basically on the two principles, which call as the mass distribution index and the heat distribution index. So basically, what are the capabilities that we can use for this software is we can check the wall thickness, weight optimization, mass distribution, ejection force analysis, draft checking, fillet radius, slider checking or slider requirement in case of hyper die casting, cooling rate, and the riser and the gate requirement. So this is what we can do optimally rightly for using the software. We call the software as a 3-click software. because it requires basically 3 clicks at 3 minutes to analyze the complete casting part. So we call it as a 3-click software. Now, how we can do this for various processes, whether you are at the product design stage, whether you are in the plastic mold or the stamping part or the casting mold. Now, for all the stages, the software can be used for different types of industry. We will, however, focus on this session for only on the casting part. Now, if I am a designer and you are the designer, or if we are in a team, and if somebody puts this casting part in front of us and say, okay, let us know where we should provide the riser, or where we should provide the feeders, where we should provide the chill, where we should provide the exothermic sleeve. So this kind of questions we upfront cannot answer by just seeing the casting part from outside. We need to study the 2D drawing. We need to spend time on the 2D drawing to understand where we should provide this riser and ingot and so on and so forth. Now, the practical issue in the current situation in the foundry is that the new generation which is coming in the foundry, they are not equipped with that much of skill who can study the 2D drawing and analyze where they should provide the riser and something like that. So eventually they depend only on the senior engineers who has the know-how to decide all this thing or to study the 2D drawing. I was recently in one of the foundry, and it was shocking for me to heard that they take complete 1 day is required for them with the team of 3 engineers who has about 10 plus years of experience in the same foundry. Once they receive the drawing or the CAD model from casting from the customer, they need absolutely 1 day to study the whole 2D drawing and decide where they should provide the riser and ingate and so on and so forth. And I mean, this is shocking in today's time. If we talk about the technology and the solution and the software, to require 1 day to analyze the 2D drawing is really shocking. Now, here today we will see how we can do the same thing without even analyzing 2D drawing from the CAD model within 5 to 10 minutes. Okay, so this is what the tool it offers you to decide upfront all these things using the CAD model. Now, the software works on basically big two concepts. One is called as a MDI, that is mass distribution index, and another one is called as a HDI, that is heat distribution index. That means we can check two things from here: how this part has a mass distribution inside, and how the part has a heat dissipation available. That means how neighboring closed or open surfaces available for the heat dissipation. Based on that, it can provide us the location which are more or less highly indicating the area which will solidify in the last and which is likely to get the shrinkage and porosity as well. So this is what we can analyze this quickly. As you can see here in this model, it is suggesting in this blue region from mass distribution index point of view, and it also indicates from heat distribution index point another two side. So we will see the practical one casting part and analyze how we can do this. Now let's take this casting part inside the software as well, where you can see this casting part is here. First, once we import this casting part, we will do the meshing of that. This is completely automatic meshing. We will not require any expertise or know-how for whatsoever for CAE or FEM side. And after that, we will see the part where it will highlight some of the portion as a transparent, while some of the portion is in the color. Now, what it means by that, that whatever portion you see in the transparent, this portion or area will solidify first, and the portion what you see in the color, that will solidify later. That means this will be the more or less, yeah, what is indicating is your hotspot or likely to get shrinkage or porosity in this region as well. So let's see this part practically inside the software. I will just open this part and will demonstrate all the steps in between what we have seen in the slides, so you will understand it exactly. Okay, so there is a question from the Sandeep here, is that can it take section variation of the casting part? Yes, it can take section variation of the casting part. I will show you how. And second question is, it requires 2D drawing or model or both? For the answer of the second question is that it requires only CAD model. 2D drawing is not required, and it allows various of import formats. What you can see here is the step, IGS file, STL file. All these formats are supported that you can import from any CAD software whichever you're using. So these are all the standard imports, exports available in all the CAD software. You can save your file in this format and then you can import it here. And another one question is that can we use actual casting for the software as an reverse engineering to get a hotspot? Any CAD model that you, whether it's part of your reverse engineering or it's a part of your new development, whatever stage you are, the software can be used both ways. But ideal use of this software is that you use it at the upfront while you are getting while you are developing the new casting part. The reason being is that when you will try to do reverse engineering of any existing casting part or the getting system design, you have already invested in your pattern. You have already your tool available, your pattern available, which is likely to change and difficult to change your say various things like location of your riser or neck size or the location of the sleeve or the location of the inlet or feeder. So that's why it is very difficult once you make a pattern to change. These things are very costly and difficult. So here we can do this at the upfront, which could save lots of cost later on. Now, what you see here is I have just imported this casting part here in front of you. And what I will do is the first step is, as I said, will require the modeling or the meshing. You just need to click on this meshing and just apply. It will automatically convert this casting part from geometry to the finite element model. So you will not require any expertise. What will be the meshing size, or is there any issue? What should be the Jacobian or aspect ratio, or whatever is the quality parameter even of the machine. You will not need to define anything. Just simple apply button and you see the part has been meshed. Now it's not the geometry anymore. This casting part is converted from the surface to the mesh model. And now we can see if I click on the MDI, it will give me the mass distribution index of this casting part. That means if I click here, you can see the mass distribution index. It shows from 3.5 to 31.6. Now this index, this value has no relevance. Whatever value it is showing does not indicate anything for us. What is important for is that if we increase this mass distribution index to the next level, you will see and observe that the casting part will start becoming transparent. Let me bring the actual casting part in the transparent mode in the background so you can see how it looks like in the background with that. So now you can see that after I increase the mass distribution index from 3.5 to 9, a certain portion of the casting part has become transparent. Means the portion which you see in the transparent color right now, this transparent region will solidify first, irrespective of the gating system even as of now. That means this is purely based on the mass inside the casting part. And if we increase further the location, further mass distribution index value, you will see more and more casting part will start becoming transparent, right? That means now what you see here is basically these are all the location more or less which will solidify in the last. That means these are the location which are likely to get hotspot or shrinkage in your casting part once you actually take trial or even in the simulation. Now what it means is basically if I am the designer and if I have to decide, okay, what should be the location of the riser, then I can see here now from this clearly. And even if we a team of couple of engineers sitting together, it is likely that we can understand that these are the locations where we should provide the riser. So this means that the software gives you hint where you should provide the riser. The software gives you hint indication where you should provide the chills. Okay, so in this way we can identify particularly location required for riser or otherwise for your location of the feeder. For example, I would say here you will also require feeder. If you see the area which is showing here is larger than the area here, both the sides. So that means this is another way where it indicates that we will provide some feeder over here that would be helpful. And for this region, what you can see here, These are the location where we'll need to provide some chills, because it will be not possible practically to provide riser for all this location where you have joining of this rib. So that means you will require some chills for this location where you can see the hotspot could likely take place in this region as well, which would later on could be converted to the shrinkage and porosity as well. Okay, we have one more question here from Sandeep again. Is it taking reference of pouring temperature chemistry while deciding last solidification point? No, it is not taking any consideration from chemical composition, solid liquid temperature, or your pouring temperature point of view. What we are analyzing is purely based on the mass of the casting part. Wherever the basic principle in the casting part, if you do not have the external cooling effect, that means you don't have external cooling of in terms of chill, or external cooling of in terms of your cooling channel like you have in high pressure die casting or low pressure die casting. That means whichever region you have the higher mass will solidify in the last, and that is the region which is likely to get hotspot and shrinkage. This is the basic concept when we speak about sand casting, investment casting process. So irrespective of your of your getting system, we need to take care of this region while providing the appropriate size of the riser or runner or exothermic sleeve or XYZ. So it address this location. First we need to understand as a designer is that where we should address this, where we should provide the riser or sleeve or something like that. That question is not answered, then it will not help if you put it this riser or astronomic sleeve anywhere at XYZ location. So we get clearly from here the critical location, and accordingly you should decide the location of your riser and chill. The another thing is how we decide the point required for chill or riser or just hot metal through ingot is ingot is enough. No, this specifies from the size of the mass. What you see here is that if you see the mass available in the color here, if you compare it with this location, it is very high. That means this location on the top side certainly will require the riser or like sleeve. It cannot be addressed by just chills. But if you see the location on this side as the connection point of this you can assume or you can predict that this location you can address via chills to overcome this hotspot and shrinkage. So based on the area in the color it shows, you can understand which one is require more complexity in terms of riser nearby or the exothermic sleeve or something like that. If the mass show is a relatively small size, that means it can be addressed by chill. Okay, so this was the purpose how you can examine this one here. As you can see here. Okay, so this question is addressed. Now we'll go further to the slides. What else we can do here is that now you can see that earlier we did not know anything about this part, but now we can all agree that yes, we will require riser on this top side, we will require the feeder on these two sides, and then we will require chills for these locations which we will help them to solidify earlier. So this is how we within few minutes we will able to identify this using this tool. Geo Designer is upfront DFM tool. Now, same way we can see we have converted this part into the gating system. That means you can provide the riser, you can provide the in-gate, you can provide the feeder and or the side riser, and accordingly you can check again with the software as well. So now you can see that if we check again with the software, we can even optimize the neck size of the riser. We can optimize the size of the riser required. What should be the rise of the diameter or height? That we can also optimize from here. Because if we find out that if the neck between casting part and riser has been solidified, then the whatever liquid metal you have in the riser will not be able to go to the casting part. So that could be also optimized here using this tool within few minutes, which is very time saving in terms of if you see whether you take compare it with the trial or even simulation. So that can save lots of time and efforts in this regard. Now, what are the other example we can see here is that if you take some examples here, these are even complex part or even large part for engine block. So if you see that if the risers are provided in this engine block, you can see riser will dry very quickly. So how can we provide further metal to the riser so we can ensure that it will keep feeding to this sections inside the engine block. Now you can see here is that if you provide such kind of top side of this, it will keep feeding this material to the engine block. and that's how you can optimize the requirement of your riser, or the runner or the feeder or so on and so forth. So this could be useful for different types of casting part irrespective of your process. It could be, as I said, will be as good as your virtual X-ray method. Now what you see here is practically the left side image on the top is showing actually the actual casting part and the X-ray result from the X-ray. That means if you see the location 1 to 9 are the actual location where this casting part has been taken in the foundry trial, and this locations where the shrinkage was found out using X-ray. If you see and compare this image with the right side bottom image, it highlights exactly the same 9 location, where it indicates that these are the locations which are likely to get solidify in the last, which could convert to shrinkage and porosity. That means within, at the RFQ stage or even at the designing stage, you know precisely which are the location which could create problem for you, and you should take care of them at the very early stage of the design, right? So this is what you can see here in this case. There's one more question, I guess. Can we consider constraint of box size while designing of risers, especially outside of casting periphery? No, I think you are talking about mold box size, but that we are not considering here as a mold box size. We are just talking about the casting part and its geometry inside. That means whatever the mass distribution in the casting part is what we can analyze from here, and accordingly we are making further decision on that. We can take some more example of different casting process. For example, you can see here high pressure die casting, and you can find out which are the area which needs better cooling channel. So this kind of decision can be also made using the same software. You can also find out where the slider will require or how many sliders will require, because in high pressure die casting, the more the slider will require, more the complexity. So the casting part at the early stage, you can identify where slider will be required, which also justifies the cost of the casting part and the complexity of the casting part as well. Same way, you can also find out the ejection force analysis. So if you want to eject the casting part from the mold, where you should provide higher ejection force, or where you will require less ejection force. Accordingly, you can decide the ejector pin size or the location of that as well, or number of ejector pin. So this kind of things can be also done using the software. You can also check draft angle of various fins or any kind of parts. You can also check radius and the fillets, minimum maximum of various casting part or even stamping parts using the same. Sandeep, you were referring earlier regarding the ray thickness of the cut section of the thickness. So what you see here, if this is the same casting part, you will see precisely wherever you will see the orange or red color, these are exactly the location where you have higher thickness. And if you see the blue color region, this is exactly the reason why this software was showing this color in the blue was solidifying the first, and the area or the location which is in the orange or red, which is was indicating which will solidify in the last. So this is how you can correlate this casting part and the images you were showing as a earlier transparent or in the color. Okay. So in summary, what we can say is that this casting part is ideally for to identify the location of chill or feeder or in gates within 5 to 10 minutes, like we have seen practically. We can optimize the riser neck size, runner location or feeder location, or even the size of that. We can identify the cooling channel requirement in case of permanent mold casting. We can identify the hotspot without spending any even simulation cost and time. So this is even saving time and cost even for the simulation. So ideally, even if the small or mid-scale foundries are there who cannot afford the casting simulation, they can do and analyze this using this Geo Designer upfront design for manufacturing tool, which is very cheap compared to any simulation software. So you can check this thick thickness, you can check the fillet or rejection force analysis or virtual X-ray method, which will highlight you the cost, and this will benefit you from the, in terms of saving of your cost, whatever you are investing in this software. So it can reduce your number of cost and ensures not any problem later on in the once you make the pattern or design. So let's do the same and check couple of parts, and we see the same and compare it with the simulation result as well as the practical result if available. we can compare this Geo Designer result with that. So I will take one another part from various processes. We have seen one from the sand casting. I will take another part from the investment casting for your reference, and you can understand how we can analyze that. Okay, so this is a part which I would like to analyze now as a couple of case studies for your reference. We are going to compare the Geo Designer result with simulation result and the practical cut section if available. We can combine three of them. So once the part will be available in the software, as I said, we will have just three steps. One step, first step would be to import the casting part. Second step would be to mesh or convert the casting part geometry into the mesh model. So this is how this casting part looks like. We have the simulation result of this casting part as well as actual foundry cut section, which will justify how this three will be correlated. So we'll just do the meshing of this part. There is one more question coming from participants. What are the advantage other than the cost part? Yes, the advantage other than the cost part is that it will reduce drastically your deciding time where you will require the riser, or you will require even the exothermic sleeve, or even the exothermic sleeve some cheap or basic cheap will exothermic sleeve will work, or we require some high-end exothermic sleeve which should be more potential or costly to address this location. So this will ensure you more or less as a thumb rule, not precisely 100%, but you will be 80% correct in deciding your riser size, in deciding your feeder location, chill will require or sleeve. So it will drastically reduce your time to decide all this thing without foundry trial and simulation. That is the purpose of that. Even you are reducing simulation time. Simulation time is itself is there to reduce the foundry trial. Now we are talking about even reducing the simulation time. So this is a reducing simulation time, and of course lots of foundry trials. So it's in terms of cost and time, both it will save to ensure even at RFQ stage you will be more or less sure how much complexity it involves. Now again, let's say this part is mesh, we'll do to the MDI, and here we can increase the MDI level. So you will understand how the part will start becoming transparent. I will bring back the original casting part in the background. Now you can see here is that these are the locations which are connected to the runners, and if we compare these locations with the actual trial and in the actual trial and the simulation, this is the result of the simulation of this part. What you see here is that the hotspot was find out in the simulation result in this location, and this is the exactly where you can see the shrinkage was find out in the actual trial. So if you compare these three, the Geo Designer, the simulation result, and the actual trial, you are assured that yes, the direction where you are working to address the complexity inside the casting part in terms of last hotspot or shrinkage porosity likely to be observed, you are working on this direction from the very first day you receive the casting part, not after some trial, not after some simulation trial. On the very first day you are working exactly on that location. Now we can take another one example of this casting part from the pump as well, and we can see how we can compare this result with another one part. So we can bring one more part. So like what I was saying is that here the software is not limited to any process. It could be any casting process, it could be any kind of casting requirements you have of from very few kgs to even tons. Now we do the modeling of this part, and you can also see there is no any extraordinary skill required, whether you are the owner of the foundry, whether you are the designer, or whether even you are the shop floor user. Anybody can use this software. There is no requirement of any expertise of CAE simulation or foundry or FEM knowledge background, nothing like that. Okay, so this part is meshed now. We can do the mass distribution index. And if we apply, you can see this part will start becoming transparent. We can bring back the casting part in the background so we can understand where it will solidify the first. Now you can see the outer, this through hole area has been solidified. Even the connection between this outer flange or outer wall is also solidified. And then you can see this is how it looks like. We can further increase this level. We can also give by manual ways as well. For example, 12, and I can also apply, or maybe 14 or 13, or I can also enter any values and it will automatically change. So now what you see here is that these are the more or less the locations which will solidify in the last, and this will clarify where you should provide the riser, where you should provide the ingate, and so on and so forth. And if we compare this result with actual foundry trial, you will see these results are one to one, exactly the same as you will find there. So if we go to that result of the simulation, in this case, you can see this is where the solidification has been observed, and these are the location where hotspot were observed. Now, if you compare this location with the Geo Designer, these are exactly the same location where it is indicating this higher mass. Now you can see that these are exactly the same location. So this way you can justify how the software enables you to decide the location of various casting part in terms of your designing. Now let's take another one model. This is bulk part of several tons probably. Let's see how it behaves with the Geo Designer and comparing with the other part. Okay, one more question is there. Is there any effect of core part in the actual hotspot section? No. See, basically, what happened is that the core is in touch or is in connection with the casting part, or even the sand mold is in connection with the casting part. But what we are analyzing here is the pattern of solidification. So that pattern of solidification will solidify irrespective of the core location or irrespective of the sand which is in connection with the casting part. We are not analyzing here the cooling rate of the solidification. That we cannot study here from this software. For that we will require simulation software. But which location will solidify in the last, that we can study from here. That is irrespective of the time of the solidification, but which area will solidify in the last, that we can identify from this one. Okay, so I think this will answer your question. Let's do the meshing. So basically, anything, the cooling effect of the chill, yes, that we can analyze here. But the core effect or even the gas or air entrapment kind of things, that will not be answered here by the software. For that we will require the simulation software, right? So the idea is that it shows you the pattern of the solidification, that will not change irrespective of whatever core you prepare. The pattern of your solidification will be the same, and we are here focusing on the pattern of the solidification, isolating of those areas which will break from the runner, break from the neck, and so on and so forth, because these are the area which are likely to get shrinkage porosity later on. Now this is part how it looks like. Let's do the MDI. We can increase this further. So the part will start becoming transparent. Okay, if we further increase it, this is how you can see that on this front we will require some ingate from this side, because it's a flat surface. You can think of providing ingate from here. You can also think of providing ingate from this side as well. So you can also check how you want to orient this part to understand the gravity, which will help for the filling or solidification. That could be also one way of getting benefited from these images. And if we go here, now you can see these are the more or less location which it highlights that these are the location which are likely to get solidify in the last. Now if we compare this image with the actual image of the solidification in the simulation and the shrinkage in the simulation, you will find out this location inside the software is exactly the same as we have in the Geo Designer. So with spending just few minutes, about 5-10 minutes, you can say this is how you can get quickly the result of that. So you can see here the locations where I want to highlight that. Now, if you compare this result in Geo Designer, this is where you are getting the shrinkage in hotspot in the solidification, and this is where you are also getting the shrinkage porosity. This is exactly the same location from first to the last. And even if you take trial, this is exactly the same location. If you do the cut section view, you will find out the shrinkage and porosity. Again, consider this two locations on the side. These are exactly where which are likely to get hotspot, and later on you can see even shrinkage has been identified inside the simulation software. So why I was saying earlier is that this can also even save the time of the simulation, is what you can see here now, that even without simulation, what we are predicting is 100% correct. We are not presuming or assuming anything which could be different in the solidification pattern, right? So what you can see is justifies the location where hotspot or shrinkage is likely, and accordingly you should think and try different gating system design to overcome this problem later on, right? So this was about this part what we have seen basically from there, and this is where we can I'll just clear this. This is where we can see this casting part behavior from Geo Designer, how it is comparable to the actual simulation and the actual foundry trials. So we have seen different parts, and where we have compared different locations from Geo Designer to simulation to the shrinkage, and then you can see how it's correlate with each other, which is more or less exactly find out the same pattern. Okay, one more case question is that, is it taking care of mold gas or core gas entrapment? No, it cannot take care of any gas or air entrapment. For that, you will require again simulation software, not DFM tool, because we are analyzing the geometry of the casting part. We are analyzing how will be the solidification pattern tomorrow if we do the simulation or if we take the actual foundry trial. So it will not take into the consideration the core or the gas entrapment, so to say, here, because it does not consider the chemical composition, the pouring temperature, the alloying of that. It does not consider liquid storage temperature, so on and so forth. That's why it will not be able to give you this. Those questions can be answered by the simulation software, not by the DFM tool. Okay, so this is what we have more or less to discuss for the day, where we have discussed various aspects how this tool can be used at the upfront when you get RFQ, or when you are deciding where we should provide the riser and so on and so forth. That is where this tool will be used ideally, and that can save lots of time, rework, cost of pattern making or change in pattern, so on and so forth. So that's why we call it as an upfront tool, upfront design for manufacturing tool. This tool is not costly. Whatever is your CAD software cost today in the market, this tool is costly as good as that. So you can justify this tool as good. You require the CAD software in your foundry, because that can save lots of your simulation trial and actual foundry trials, and you can identify those hotspot and shrinkage areas without any foundry trial or even without simulation. That is the real return of investment of this cost. If any smaller foundry, smaller mid-scale foundry even use this tool, they can get return of investment of this tool within new 10 to 15 development. Within 10 to 15 development, which is likely to get in 3 to 6 months of time, even with frequent new design. Even your risk will be low. You can at RFQ stage understand how much you should charge to the customer, because you understand the complexity of the casting part. So even if you do not use it at the development stage, let's say for a worst case, even at the RFQ stage, you will get benefit of that. Even as the owner of that, you can use it within 5 to 10 minutes. So this is how the software can be utilized at various level by various department, whether it's a shop floor or the sales team, or even the designer or actually simulation engineer. Everybody can use this software from different stages of the foundry. One more question which is coming is that, is it take care about the sleeve types like exothermic sleeve or HDS? Yes, it takes care. How it takes care is that, what you see here is that if the area which shows very less mass, those area you can say will work with with the low density sleeve, but the area which is showing a higher mass, you will require costly or high exothermic sleeve with high density to address those area. So depend on the mass it shows in the Geo Designer here, you can suggest, or based on your experience, once you start using the software, you can analyze three things. Certain area which shows Geo Designer can be addressed through chips. Certain area and mass which shows Geo Designer can be addressed by traditional riser, and certain area which is a very high mass region it shows in the Geo Designer has to be addressed by your sleeves only, exothermic sleeve, or if it's even more area it shows, then even costly or high density sleeve. So that is why it gives you answer to all these questions, which is not known from outside at the early stage of the designing. Only by learning and by trial you are deciding this thing, which you can decide at the early stage. Another question is that cost of this software. The software cost is around 5.5 lakh plus minus. That will be that this cost is based on that justifies, as I said, as good as your CAD software. So whatever you are investing in CAD software, these are for your development of your CAD model, 3D model. Here you can record all this part, how you have solved your problems. If you are finding the shrinkage in certain area, for example, practically you were finding issues with the shrinkage in this region which you are not able to solve for long term. So if you get shrinkage or such location in any other new casting part, you will remember from this GeoDesigner images that okay, this kind of casting part has struggled. I mean, in our foundry we have struggled a lot. So whenever such similar part you will receive from GeoDesigner image, you will be able to visualize that no, this type of casting parts are very complex and we have stuck or we have even lost our money without any profit. We have produced this casting part. So this is also for your complete casting part as a life cycle. You can also save and understand which parts are very complex for your foundry to make, which parts are very easy to make for your foundry. That will start developing the base for your foundry to understand what is the ideal part for my foundry to produce. And then you will start making profit on that because you know the target part as per your foundry, your alloying, your furnace size, your mold work size, so on and so forth. Okay, one more question is there any source from where service of for this software can be given or taken? Yes, this software, as I said, is from the C3P Software, which is a US-based company. Auto Design Online is the first company and the distributor of this company, the software in India. We do provide sales and service for the software, as well as we have casting simulation software where we can do the complete getting system design inside. We can do the simulation inside for complete filling, solidification, deformation, shrinkages, micro porosity, microstructure, niyama, so on and so forth. So there are so many things this software can be do. As a Geo Designer is an independent DFM tool. We do provide service for that. And the another one what we do is a Cast Designer, which is a casting simulation service, casting simulation software. And for both of these solutions, we do provide service as well as we sell the software in India. So for any of your query from service point of view or from sales point of view or demo request point of view, feel free to contact us any point of time. You have our email address as well as the contact details also available here. You can contact us anytime for any of your service requirement or for any of your sales or purchase requirement you have for the software as well. How does it connect to microstructure of the material? For this software what we are talking about, Geo Designer, that cannot taken care of any microstructure because it does not consider the chemical composition, pouring temperature, alloy, and so on and so forth. But Cast Designer, which is a casting simulation software, can take care of your microporosity, microstructure, and so on and so forth. So simulation software can answer to these questions of microstructure, not the DFM tool. Okay, one more question. Is there software is for all metal grades and material? Yes, the software is for all metal. It could be your high pressure die casting, low pressure die casting, hill casting, sand casting, investment casting. It could be anything because we are talking about mass of the part, whether it's aluminum part or whether it's a sand casting. But of course every process has their own requirement. For example, for high pressure die casting, they can also find out which area will get transparent or will solidify the first, because it is also critical for high pressure die casting to ensure that in that region it should not create any kind of turbulence which could create later on a gas or air entrapment, which could also create shrinkage and porosity. So from foundry to foundry process, it could be have a different requirement, but yes, it is irrespective of metal can be used. It could be even used for plastic part, or even the stamping part or forging part can be also used. Okay, any other questions for the day? Okay, I guess no. So we have the first session of this webinar here. I hope everybody has enjoyed this session. We have very questions answer sessions where participants are sending their questions frequently in between as well. So I hope you have enjoyed these sessions, and feel free to contact us for any of your requirement. And I hope we have more such webinars in the future as well. Wish you all the best. Enjoy. Bye.